3.3b. This one I just had on the board. I'm going to teach you a different way of doing it. In fact, let's make it positive, so we're not even messing with those two negatives anyway. Two negatives is a positive, so it ended up with a positive number anyway. But one of the things that you can do before you multiply, you can change these fractions into their prime factors prior to multiplying, and then when you get the answer, like we got 72 over 36, then that has to be reduced. It would be nice if when we got our answer we knew it was reduced and we didn't have to go any further. So that's what we're gonna do on this one here. So instead of getting 72 over 36, we're going to get the answer 2 without having to reduce that 72 over 36. So the way you do that is you take each one of these 4, because they're smaller, so they're going to be a lot easier to find the prime factors of than 72 was, or 36, or some of the other ones that we've had that were larger. So if we take the prime numbers prior to, it make life a lot easier. So for example, 9 breaks down to 3 times 3. 2 is itself, nothing can be done there. 8 can be broken down to 2 times 2 times 2. 18 can be broken down to 3 times 3 times 2. So all I did, which we can even put the parentheses here if you want to make it look the same as what it was up here. Might be better to do that. So now that we've done that, we can look at all the numbers on top, all the numbers on bottom, and start dividing out. Well, I have a 2 and a 2. I have a 2 here and a 2 here. I have a 3 here and a 3 here. I can go across. It doesn't matter when you're multiplying. You can use different numbers or different sides and cross out and be good to go there. Which leaves me with, oh, there's a 3 here and a 3 here. Which leaves me with my answer 2. This way you know that your answer that you get is reduced to its lowest terms and you're done. You don't have to do anything else. Let's try that on one of the other ones that we did in 3.3a. Let's try 15 over 8 and multiply that times 4 over 9. Alright, let's write this out. 3 times 5 would be 15. 2 times 2 times 2 would be our 8. 4 can reduce to 2 times 2, and 9 can be reduced to 3 times 3. Alright, well let's start dividing through here. We've got a 3 here and a 3 here. We've got a 2 here and a 2 here and a 2 here and a 2 here. And we're left with a 5 on top, and we're left with a 6 on the bottom. So, we get 5, 6 as our answer. It's already reduced, and breaking these small numbers in a product of primes was a lot easier than multiplying them across and getting 60 over 72 and then having to make a factor tree for 60 and a factor tree for 72. So if you could break it prior to multiplying, it's going to be a lot easier in some respects than multiplying through and then reducing the answer. Both ways are correct. I'm just trying to help you come up with a way that might make life a little bit quicker and easier, because I know you have other things that you'd rather be doing. Alright, so let's put these up here. Let's make this a 3. Notice these things here in the denominator. That is a z. Okay, my 2's and my z's look very similar, so I put that little mark through that to show you that it's a letter. It's the letter Z, not a 2. So that's what that nonsense is, as you're wondering what the heck's going on here. Alright, so we've got that. All letters, no numbers. So what we're going to do is what we did before, is we're going to write them out. We're going to expand them. So instead of writing x squared, we're going to write x times y over z, my little line, times, and z, we're going to do that 3 times. And that's going to be over x times y. Okay, now we're just going to start canceling, dividing across. So I'm going to divide my x with this x, and let's see, I've got a y here, and a y here, and a z here, and a z here. So I end up with x times z on the top, x times z, and what do I have on the bottom? I don't have anything. So whenever you don't have anything on the bottom, you have two choices. You can put it over 1, because remember I said there's a 1 there. Or because it's on the bottom, you don't need to put anything. Okay, so we just have x times z times z. Now we can go back to this way of writing it. Xz, and since we have 2 of them, we can write it as xz squared. So, nothing different as far as doing the letters compared to the numbers. In fact, the letters are easier because you don't have to do anything with prime factors. You just take your x to the 4th, and the prime factors of x to the 4th is that x written 4 times. That's all there is to it. So actually the letters are easier to use than the numbers are. Let's see, if we were to jump down to example number 12 on page 186. It says find 1/2 of 2/3. Well, let me give you another clue here. Might have done this before in a previous lesson, but let's just go over it again. The word of means multiply. The word is means equal. So if you can get that down, you'll be good to go on these. Example 12 says find 1/2 of 2/3. Find 1/2 of times 2/3. Gives me 2/6. Now I reduce. 2 is already its prime factor, so it's going to stay. 6 can be reduced to 3 times 2, and these 2's go away, and we are left with 1/3 is our answer when we multiply that out. Alright, well, let's finish this section with the area of a triangle. The area of a triangle, actually the area of a triangle is always half the area of a rectangle. So if you take a rectangle or a parallelogram, if you take any figure like this and you divide it in half, one corner to the next, and get a triangle, you're going to get 2 triangles, which means that you've got half of a parallelogram. So what we've got here is a triangle, and we're going to try to find the area. Well, if we know the area of a parallelogram, or which a rectangle is part of, is length times width, or in this case, because it's going up and down, height, then the area of a triangle is going to be 1/2 that length times the height. But rather than calling it length on a triangle, they call it a base. So they call that a base, and then the distance from, and they will give you this, the distance or the height will always be from one point of the triangle down to the base, and that angle will be a 90-degree angle. You'll notice in page number 187 they do put a little box here to show that that's a 90-degree angle. It just means that it's straight up and down from the base. It's perpendicular. And then that's the height. So the area of a triangle, that's a triangle, equals 1/2 the base times the height. So if I gave you in this particular one a height of 7, and I told you that the base was 10, you would take 1/2 times the base times the height, which is 7, and multiply those out, and you would get, well, what's half of 10? 5 times 7 is 35. That's all you do. Or you could take 10 times 7 and get 70, and take half of that and get 35. Either way. Alright, so that's it for lecture 3.3.